All right, this video is for Tuesday, the 28th of April, and as you watch this video and head into this, give you a little preview of what's going to happen. There will be an assignment for Tuesday, for Wednesday, and for Thursday. I'm going to give Monday and Tuesday of next week, which are the days, of course, that we, the final days of the school year. I'm not going to put new assignments up. What I'm going to do is I'm going to accept late assignments on those days for diminished credit. And if you have all your assignments in before the weekend, which since we have a 3-day weekend, that means before Friday. That means by Thursday night. If you have all your assignments, you're all caught up on everything, then I'm going to give you 2 free 100s for Monday and Tuesday. Just a little say, rock on, you're awesome. Unfortunately, some students have fallen behind. Some are just a little behind, some a lot behind, and grades have really plummeted for those of you. Even though we haven't had quizzes and tests, all you've had to do is to watch the videos and do the worksheet. Grades have plummeted, and you know what that is? That is stupid. So if you've been acting stupid, fix it, okay? All of the assignments are still up. I've emailed them to you. They're on the Easy Class website. I will email them to you again. I've got them on a flash drive. I can send everything to you, but you've got to be proactive. You've got to be the one that's asking me for these. You ask, you receive. You don't ask, you get a 0, all right? So last week we worked on the concept of simplifying radicals. And during this coronavirus, basically what I've done is I've taken the list of skills that are needed to move on to the next level in your high school mathematics, and we've applied those. So for some of you, you're going to be moving on to geometry next year. Others will be moving on to Algebra II. Just depends on what enrollment looks like. We might end up doing some different things. But anyhow, everyone's got to have, in order to get a Kentucky diploma, you've got to have Algebra II and you've got to have geometry. So we've just been going over some of those core skills. And simplifying radicals, that's like a square root, a cubic root, a fourth root, etc. That's one of those skills you have to have. Well, this week we're going to focus on transforming quadratic functions. Now that sounds like a mouthful, right? Transform, what does that mean? It means to change. What's a quadratic function? Well, a quadratic function is anything that has, I'll just give you the simplest quadratic function in the entire world. It is the function of x equals x squared, okay? We might just as easily write that as y equals x squared. Because remember, that's what that f of x means. Function of x just means that it's y, but it's y all the time, okay? It's not just one particular y. This is a y you can count on. That's why we write it in this funny way. But really, if you have y equals x squared, you have a quadratic equation. All right? This being the simplest quadratic equation, which is y equals x squared, we call that the parent formula or the parent equation, because it doesn't have to be just y equals x squared for it to be a quadratic equation. It can be, for example, y equals x squared plus 2, still a quadratic equation. It's just been transformed. We took y equals x squared and we did something to it. So what does it mean to transform? Transform means to move, to change its size, okay? You might remember that the general shape of y equals x squared is a parabola, right? It looks like a real smiley face. Something like that, okay? And this is y equals x squared. If we'll get, and this line is actually, this is our y, this is our x, and then we call this a parabola, okay? Basically what this means is that for any x, you choose the x, and so you choose the number, whatever number you want to put in there, and if you'll square it, that gives you the value of y. So the square of x is the value of y, right? So sometimes it's so simple that sometimes you'll turn around in your brain and you'll mess that up. So another way of thinking about it, but it's not as fun because it's not as easy, is to make it a radical and say let's take the square root of both sides. In other words, the square root of y equals the square root of x squared. Well, we know what the square root of x squared is. It's x, right? So that would be the square root of y. The square root of y equals x. Well, who wants to deal with the radical all the time? But just remember that, okay? If you know what your y is, you can take the square root of it and you can find your x. However, it's a million times easier just to think about it this way. Now, anytime you're going to graph a function, the first thing you're going to do is you're going to make a chart. You can make it vertically, you can make it horizontally, it doesn't matter, but an x and a y. And then you just plug in numbers for it, right? Now, when we were talking about radicals, let's get back to writing it as y equals x squared. We were talking about radicals. We were thinking ahead and saying, let's make this easy. If I get to choose whatever x in the world I want, then let me choose numbers that are going to be, related to a square root. Well, we don't have radicals if we're looking at y equals x squared. So I just want to point out one thing. If y equals the square of x, it is impossible, unless you do something different to it, you're just looking at y equals x squared, it's impossible for y to be a negative number. Let me show you why. If I drop in a 0, in other words, y equals 0 squared, that'll equal 0. But what if y equals, and I choose a negative 1 for x? Well, what is negative, I'm sorry. What is a negative 1 squared? Negative 1 times negative 1 is a positive 1. Okay? So y is going to stay positive. When I go to graph this, there will be no negative y's because I'm just going to be squaring my x. So let's think about this. Positive 1 would also be 1. Positive 2 would be positive 4. And a negative 2 would be a positive 4. Because if I go back here and I drop these numbers in for x, and then I just take the square, so x squared is 0, or 0 squared is 0, negative 1 squared is 1, positive 1 squared is 1, positive 2 squared is 4, negative 2 squared is 4. Right now you're just looking at a whole bunch of numbers. But let's talk about what that looks like when we get it on a graph. I don't have a whole lot of room here. Let me move my camera around like this, okay? Now, there's not going to be any negative y, so I probably didn't need as much line there. But here's my y axis. Here's my x, okay? And let's mark it off. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, positive 1, 2, 3, 4. All right. So here are my ordered pairs. Okay? So I have x equals 0, y equals 0. I just put a big dot there. This is how I'm going to graph it. All right? X equals negative 1, y equals positive 1. X equals positive 1, y equals positive 1. X equals positive 2, y equals positive 4. X equals negative 2, y equals positive 4. And what's this give me? This gives me my parabola. Okay. Now, remember, this is just a graph of a quadratic equation. This is the most basic, simple quadratic equation in the world, y equals x squared. And you notice that the tip of the parabola comes down and perfectly touches the origin of our graph, 0, 0, okay? And then it goes up equal. Now, my lines aren't perfect, but if they were perfect, you would see that these are constantly moving in the same kind of parabolic shape, okay? So a transformation of a quadratic equation is when I do something that looks a little different. Okay, let's say, for example, that I changed it so that my parabola had the exact same shape, but its tip just touched something other than the origin. In other words, if it came down, it's exact same shape, and it came down and it did like that, okay? That is a particular kind of transformation that we call a translation. To translate just means to move left, right, up, down, okay? The size doesn't change, the shape doesn't change. We've just moved it around. It might look like this, okay? I have translated. To translate means to take the exact same shape and just move it around on my graph, okay? That's what we're really going to work with today. However, the next couple of days, let me preview, we might do a couple of other forms of transformation. So there are three kinds of transformation. Okay, there are three kinds of transformation. The translation just means to move around. A dilation means to make, when we're talking about a parabola, skinnier or wider, okay? And we'll talk about that tomorrow night. So if I were to come up with a parabola and it was skinnier than my parent or my basic y equals x squared parabola, I'll tell you what I've done to that. That is y equals some number greater than 1, right? So this one might, right here, might be y equals 2x squared. So if I add a number that's bigger than 1, my parabola gets skinnier. Okay, that's a dilation. It's getting skinnier. If I give a number that's smaller than 1, surprisingly, if I did this, my dilation would lead to a parabola that was wider. Still a parabola, it's just wider than the original y equals x squared parabola. So that's another kind of transformation. So again, to transform just means to change. So anytime we change it, it's a transformation. And there are three kinds of transformations. One is a translation, move it around. One is a dilation, make it skinnier, make it fatter. We'll do with those in tomorrow's worksheet. And then in Thursday's worksheet, we'll deal with one called a reflection. And a reflection just like seeing yourself in a wading pool, a reflection flips it upside down. Literally, it flips it across a line. Now, it is possible for us to write a formula that does all three transformations. In other words, it translates it, it moves it around, it dilates it, it makes it skinnier, fatter, and it reflects it, or it flips it over on a line. So the fun thing, though, I think it's fun, is that when you begin to look at these formulas, you will look at it, and just by looking at the formula, you will be able to say, oh, that dilates the parabola. You might have to graph it to see exactly what it looks like, but I'm going to teach you how to look at the formula and say, oh, that's been translated, or that's been reflected, or that's been dilated. Those are three big ones right there, okay? So let's look at what a translation looks like, okay? So if I'm talking about translating, again, the parabola is going to keep its same general shape. It's just going to move around. Let's say, for example, that I gave you a new formula. I said, I'm going to leave this original guy up here, okay? This is y equals x squared, but I'm going to give us a different one, right? What if I said y equals x squared minus 2, okay? So what does y equal? Well, you take x and you square it, then you subtract 2 from that, all right? So let's make our little chart here, our table. I'm going to put x over here, I'm going to put y over here, and I'm going to choose the same values for x that I did just a minute ago, okay? I'm going to say 0, -1, +1, -2, +2. Now, let's put those numbers one at a time into our formula. Y equals 0 squared minus 2. Well, what happens? Y equals negative 2. So when I go to graph this, my first point is going to be down here. Okay? Let's put our next one in. Y equals negative 1 squared minus 2. Negative 1 times negative 1 is a positive 1. So a positive 1 minus 2 equals a negative 1. So when x equals negative 1, y equals negative 1. So here's x at negative 1, here's y at negative 1. I'll put my dot in here. This, by the way, was negative 2. Here it is. Okay. Well, by now, and I'm sure you don't need me to go through all of these, if I square this, 1 times 1 is 1, subtract 2, that's going to give me, well, let's just go through here. It's going to give me the same number, right? 1 times positive 1 squared is a positive 1, minus 2 is still a negative 1, okay? And a negative 2 squared is a positive 4, minus 2 is a positive 2. And we get the same number over here, okay? In other words, look what happens to my parabola. When x is positive 1, y is negative 1. When x is negative 2, y is positive 2 and positive 2. And notice what happens. I have the same parabola that I had with y equals x squared, but by saying subtract 2, what's the difference? There's only one difference, okay? Hint, 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 hint. If I've got x squared minus some number, that minus some number or that plus some number is the point on the y-axis where the tip of the parabola touches, okay? So this and this are the same, all right? Now, what you're going to have to do is I'm getting ready to write a few formulas on the board. You're going to copy them down. This is what you're going to do for your homework, okay? For every one of them. Now listen, some of you will have skipped through my explanation and you will try to get just to what I'm getting ready to do right now, and I will throw this back in your face. I don't want it. I want you to do this work. It's not hard and you're not dumb. I don't care what your grown-ups say about you. So here's what I want you to do. I want you to, with every one of these, set up a chart, an X, Y. Now, we did it tonight vertically. We did it when we were working with radicals. We did them horizontally. I don't care which one you do. It's an X, it's a Y. And then whatever the formula is, pick an X. Where do you get your X? Just pick it out. Hint, hint, hint. There's a reason why I chose these. Okay, you got to start somewhere. Why not 0, negative 1, positive 1, negative 2, positive 2? Why not start there? Okay, if you want to do negative 17 and positive 17, go for it. But you're going to have to use a lot of paper when you graph. Be smart like your teacher. All right, so here are the ones that I want you to graph. And again, this is a particular kind of a transformation called a translation. And I'm going to give you some examples here. And it's going to be directly from the textbook. Okay, so let's do this. I'm going to give you 4 of them, okay? Number 1 is x squared plus 3. Number 2 is x squared minus 4. Number 3, okay, now you're going to have paid attention to this particular process. I didn't do an example of one of these. However, it's not hard. You're just going to need to solve for x to find your y every time. All right? Let's do And you know what? Let me write this out with the y equals. I'd feel better. Y equals, y equals, y equals. This is what this one's going to look like. X plus 1 squared. Okay? And number 4, y equals x minus 2 squared. All right? So those are your 4 assignments. And again, you're not going to be able to get the correct answer if you don't build an XY table where you just pick numbers for X. You use the numbers that I use. Don't be dumb, okay? And fit those in. And for every one of those, so you're going to have 4 XY tables. You're going to have 4 graphs, right? That's what I'm looking for. I know that you can do this, right? I know that you can do this. And then we'll talk about other things as well. Peace.